Three members log.
Yeah, good evening, guys. Welcome to the day two session of microprocessors and microcontrollers. Uh, Before we start today's session, can we have a discussion about yesterday's webinar? Can you tell how insightful you found it, or did you do any research regarding yesterday's topics, like what you found out new about these daily used robots or something which you say is seen day to day life? Anybody, anything, any answer, or anything you tried to observe in your daily life where you could find the application of these robotics? Anyone, you can raise your hand or you can type in the chat box. It would be better if you unmute and speak.
Bro, I have got something to
Otherwise,
ask you.
yeah, go on, Karthik.
Bro, the technology used in autopilot in aircrafts and Tesla are similar to robot technology.
Sorry, come again. Your voice is
The
breaking, Karthik.
technology. One sec. Can you hear me?
Yeah, right.
The technology used in autopilot in aircraft and Tesla are similar to the technology used in robots.
Answer to this question is in almost upcoming sessions, because what you are asking is actually depending upon how uh, the perception is taken. Like when an aircraft is flying, the aircraft has some ways of perceiving, like how much altitude at the aircraft is. And coming to the Tesla cars, the auto driving cars, um, it has some lane detection and other requirements whichever it needs. So answer to this question is in upcoming sessions, so you will see to that soon, today and tomorrow.
Okay, bro. Thanks.
Yeah, anything else others did research about, or something they found out yesterday? Guys, be interactive. Your other fellow mates will also come to know from you, and sharing knowledge is anyways divine. And so yeah, we encourage you to participate in interactions. There's nothing to say, then was yesterday's session boring, guys? Give an honest review, or at least type in the chat. Yeah, Dwaraganath, I was asking, like, did you try to find any insightful articles yesterday or something regarding robotics? That was my question.
No, recently MI has launched a cyber dog. Have you heard of it?
Oh, nice. I didn't
Hello.
hear about that. Can you go on? Can you tell us what it
Yeah,
is?
it's cyber dog. It's actually they have designed the robot which from dog, actual dog. It is actually an bio-inspired robot. It has the ability to sense
So
his owner. It behaves like actual dog now.
Yeah, Boston
so
Dynamics has
Hello.
started that project.
Hello, am
Hello?
I audible, bro?
Yeah, you're
Yeah.
audible. Do
Okay,
you
bro.
know the Boston
Definitely,
Dynamics
bro.
arm dog?
Boston.
Boston Dynamics.
No, bro, I haven't heard about it.
Just check that out. It will be quite good. Once you will get to know
Okay,
what is
bro.
such a dog is, you'll get to know how we can use our robotics in this.
Yeah, bro. Thank you, bro.
Yeah, anything else? Any other input from anyone? That was a good input, Dwarganath. Thank you.
Thank you, bro.
Yeah, if that is it, then yeah, we are good to go. Everybody on board, you're welcome for day two session, Microprocessors and Microcontrollers, presented by Team RCS. So, have you ever wondered how a robot thinks? What drives it? Just compare with your brain itself, like how a human brain functions. What does biologically happen is you have some similar to end effector. Your hands can be regarded as end effectors, which such as you can take an example of a frying pan, and when you touch it, the frying pan is the stimuli, and as soon as you touch it, your brain gets a signal that you have touched something very hot and it may harm your skin, and you need to then it goes for processing to your brain, and your brain finally gets output that you need to pull your hand back, and accordingly signals are sent to the hand nerves, which actuate. The term actuate, please make note of it. You will be soon seeing it what it is. In basic terms, it is pulling back hand here. So that is actuating any kind of act, such as here in this case, it is pulling back your hand. So that is actuation, and so the same has to happen with the robot as well, because the robot is something which you are designing. Like you'll give input to the robot, and it has to process and accordingly generate the output and has to act accordingly. So that is what we are going to see today in terms of technical knowledge required for that. And this session will be handled by Dinesh Kumar. So I'm handing over dais to Dinesh. Yeah, you can go on.
Am I audible?
Yeah, Dinesh, you're audible.
Thank you, Dheeraj. That was a good introduction. So, hello everyone. We are the team of RCS Robotics Club at Sastra. I'm here to present you today on the topic microprocessors and microcontrollers. So we will moving to the next slide. Ritvik, can you change? Guys, I'm still audible, right?
No, you're a bit lagging. Yeah, you're audible.
Sorry. So today, Parthiban from CSBS department, Ritvik Perla from EC department, and myself, Dinesh Kumar from Mechatronics department, gonna be hosting this session. So today we are gonna be seeing about microprocessors and microcontrollers, right? As Dheeraj has already used the analogy between a robot and a human brain. Yes, the human brains stores data, like we remember things, we process, and we react to the environment accordingly. The machines or robots also do so. But how do they do that? Yeah, they also require a brain, right? Uh, so, so we are going to be discussing in detail. We are going to be discussing about them in detail today. First, starting with the architectures. So, you know, this is the basic fundamental idea behind how the microprocessors or microcontrollers are built, which will be handled by Parthiban. And then we'll move on to microprocessors. I think you all might already know about microprocessors, right? Can you just list out the microprocessors out there in today's trend? I mean, which is the latest microprocessors you have seen? Just put it up in the chat box. Just let us know what you know. Guys, what? I just want to know what kind of microprocessors you know. Hi. Come on, guys. You have to. I think you all might know about microprocessors because we all have in our hands, inside a mobile phone, a laptop, right? Come on, I just want to know how many of you know about microprocessors and what kind of microprocessors you know, or at least tell me which is the most powerful microprocessor you know. Come on. Intel Ryzen,
First
yeah,
of all,
Intel Ryzen.
hello Dinesh, am I audible?
Yeah, bro, you are audible.
Yeah, sorry for interrupting. So, how many of you have joined this session, particularly with your laptops? Would I have some reaction?
Oh, that's nice.
So, what kind of processor does your laptop utilize? Based on the manufacturer, Intel, Ryzen, yeah, majorly these both are the huge companies. So yeah, that's it. You have an answer in your hand. As well as the
Yeah.
same thing, list out the processors that are utilized in your mobile phones. And this question is to the participant. You can open up your mic and tell it out loud or put it in the chat box.
Yeah, that's really nice. Yeah, Snapdragon, Qualcomm, yeah, Exynos. Okay, guys. Yeah. So there are a lot of microprocessors. But do you know about a microcontroller? I can you can just raise your hands if you know about a microcontroller. I want to see because, yeah. Okay. Krishna knows, Priyadarshini, Karthik. Yeah, that's really good actually. Most of us, they don't know about microcontrollers. It's really a good thing you know that about microcontrollers. So yeah, microcontrollers is a major part of the robotic system. And we will be discussing about them in detail today, and which will be handled by me. And moving on to the microprocessor versus a microcontroller, we'll see, we'll compare a microprocessor with a microcontroller, and we'll get to know why a microprocessor is used and why a microcontroller is used in specific applications. So yeah, we'll see about them. And last but not the least, and we also need to know how a robotic system or a machine is being controlled, right? To know that, we'll be seeing about a control algorithm, which is pretty intriguing. So yeah, so please pay attention and enjoy today's session. Enjoy the today's session. Ask as many doubts as possible. I think you'll gain a lot of knowledge from this session, guys. So first, the architectures will be handled by Parthiban. So I hand over to Parthiban now.
Thank you, Dinesh, for for giving an introduction about the concepts which you are going to see today. And good evening, one and all present here. I am Parthiban, studying in CSBS department in third year in Sastra University, a core member of RCS. Let us go into the concept. Today I'm going to give a brief detail about an interesting concept called as architectures and its types. What does the word actually mean, architecture? Just a simple meaning. Does anyone know? Come up with the answers. You can turn on your mics. Architecture.
A set of rules that one has to follow.
Okay. Anybody else?
Design of the building.
Sketching out the plan.
Yeah. Yeah, that's what I expected too. The design of a building or the set of rules that we follow. Okay. Computer architecture is nothing but the set of rules and the methods that is used to develop the hardware and arrange the hardware and software systematically so that we can see how the computer system is implemented. And it is divided into two major categories based on. Next point, please. The architecture is divided into two subdivisions based on the instructions, and the other is based on the bus and the memory. Based on the bus and the memory, it is divided into two von Neumann architecture and Harvard architecture. And based on the instruction, it is divided into two, CISC and RISC, complex instruction set computer architecture and reduced instruction set computer architecture. Now let us go one by one. Von Neumann architecture. Before going into this, does anyone know about fixed program computer and a stored program computer? Any idea? Anyone? Texting? Anyone? Okay, I'm giving you the answer. Fixed program is nothing but a computer which is designed for doing a particular task, like the calculators is called as fixed program computers, whereas stored program computers are nothing but a computer which is used for doing multiple tasks on certain applications. Now coming into von Neumann architecture, it was proposed by as the name suggests, it was proposed by Sir John von Neumann, and in modern computers, this architecture is majorly used. Let us see what this architecture says. In this type of architecture, actually there are two important concepts. One is the instructions and the other is data. Instructions and data are stored in a storage unit called as memory. Both are stored in only one storage unit called as memory. Make it clear and make that point remember, so that it will help in differentiating the other architectures. When both are stored in the same memory, we come up with a small problem called as the instructions can only be executed one by one, which will be carried out sequentially. Due to this, the CPU's efficiency will be reduced. This problem is called as von Neumann's bottleneck problem. As the instructions and the data both are stored in only one memory unit, the time taken to transfer data will be little longer. Can you understand one point? Am I clear with it? Anyone? Yes? Any doubts?
No, bro. When someone wants you to repeat.
Someone wants to repeat.
Someone wants you to.
Dheeraj, can you be a little louder?
Just repeat the concept once again, Parthiban. Someone wants to hear about it again.
There are two important things in it. One is the instructions and the other is data. Both can be stored separately also, but here in von Neumann architecture, both are stored in a single storage unit. Storage unit is where we store the data and instructions kind of things. So when we store both of them in a single storage unit, this architecture is called as von Neumann architecture. In this architecture, what actually happens is the instruction as well as data both are executed one after the other sequentially, as they both are situated in a one storage unit, so they can be executed only one after the other. Due to this, like when we execute parallelly, we may overcome the problem of time wastage, but here as they are executed one after the other, CPU's efficiency gets reduced. This problem is called as von Neumann's bottleneck problem. Though the name is something different, but the problem is very easy in understanding. So to overcome this bottleneck problem, we are going with the next architectural type, that is Harvard architecture. Let's pick next slide, please. Okay. When you see the previous image and this image, you will get to know the difference between von Neumann's architecture and Harvard architecture. Here, in this computer architecture, it contains two different buses as well as two different storage units for storing the instructions as well as the data. But there in von Neumann architecture, both are stored in one storage unit. That is a major difference. So the instructions can be executed parallelly along with the data. As there are two different storages, we can execute it parallelly using the concept called as pipelining. Pipelining is nothing but executing the instructions and the data parallelly. Like when the instruction is getting executed and traversed, the data can also be executed and it can be moved to the control unit. This transfer of data from here to control unit can be done using the buses. The major function of communication bus is nothing but the transfer of data. And pipelining, this is the main advantage. And using this, as there we have only one storage unit and here there are two storage units, so the problem of bottleneck von Neumann architecture can be overcome here. Now, can anyone tell what is von Neumann's bottleneck problem, as I said before? Anyone?
At least you can type in the text box, guys. We'll give you 1 minute, 2 minutes for you.
I mean, there is sequential execution of the instructions and the data in the bottleneck problem, von Neumann's architecture. So in this case, it's parallel.
Yeah, that's exactly right. What she said. In von Neumann's bottleneck problem, it is executed sequentially. So due to that, CPU's efficiency gets reduced. That's the major problem. But here, both are executed parallelly, so efficiency can be increased. That's what comes here in Harvard architecture. Now let's go on with the next type of architecture, CISC and RISC. I have showed you the abbreviation of CISC and RISC. Can anyone say what is CISC and RISC? The first letter, at least the first one, R and C, what does that mean? Okay, CISC. The full form of CISC is Complex Instruction Set Computer Architecture. RISC is Reduced Instruction Set Computer Architecture. From the word complex and reduced, does anyone get to know about the concept? It is very easy. Complex instructions and reduced instructions. Okay, let me explain about it. CISC generally focuses on hardware. It generally focuses on hardware kind of thing, and whereas RISC focuses majorly on software. Here in CISC, the instruction sizes, the instruction or the program sizes may be differed. There will be multiple instructions which will have different sizes. Whereas in RISC, the instructions will have only a same particular type of size, which makes it very easy to execute. So in CISC, the registers that are being used is very less, but in RISC, the registers which we are using is a little bit higher. And CISC is complex instruction set, right? So the instructions that we are going to be used is very complex. So these are going to be stored in a very small unit called as microprogramming unit. All the instructions are getting stored in a unit called as microprogramming unit. Whereas in reduced instruction set architecture, the instruction is going to be only one, but the execution of it is going to be a little bit tougher. So the complexity is occurring in the compiler or the executor. In the complex instruction set architecture, the instructions will be more, the instructions will be less, but the cycles executing for it will be more. Whereas in RISC, instructions will be more, but the cycle which it is ready executing will be very, very less. That is only one. Instructions will be only one clock cycle time. But due to this, I have said before, the instruction sizes will be varying in CISC. So due to this, the pipelining, which I said in before concept itself, is going to be tougher in CISC. But in RISC, the instructions are of same size. So it is going to be, the pipelining can be very easy as the size of the instructions will be same. So the pipelining is going to be easy. Next slide, please. As I said before, RISC, reduced instruction set architecture. How many cycles does it have? I said in the before slide, how many cycles does RISC architecture have?
One.
Yeah, exactly. That's there in the image itself. RISC, you can see the machine instruction and it is directly executed. It has only one instruction, whereas in CISC, it is divided into, subdivided, and it is made a little bit complex so that the machine instructions are converted into microcode, and then it is converted into micro instruction, and finally it is getting executed. Here it is only one instruction, here there are many instructions, and here the software is getting used, and here the hardware is majorly focused. It goes on like that. And now, why are we using these kind of architectures, and what is the use of this architecture? Where are we using it? What is the use of it in microprocessor and microcontroller? Will be discussed by Ritvik. This session is now, the next contents will be taken through by my friend Ritvik. He'll take you through the concept microprocessors. Thank you. If you have any doubts, you can ask.
Yeah, guys, feel free to ask your questions. If you have any doubt, if you want them to repeat anything. If not, I will go into the next concept. Okay, is everyone clear? If you're clear, you can raise your hand. If you're not clear, you can ask your question in the text box. Yeah. Okay, only 2 of them are clear with the concept. Okay. Fine, guys. Myself, Ritvik, and I am from 3rd year BTech Electronics and Communication Engineering. So everyone has a question. Where are we using microprocessor? Where are we using microcontroller? And what exactly does a microprocessor do in your laptop or any gadgets, smartphones, anything? So basically, can you answer in just simple words? Not doesn't matter on technical terms. Just what a microprocessor does. 3 simple steps, or just 1 step what it does. What is a microprocessor? At least what is the use of the microprocessor in your gadgets? You can type in the chat box. Answer. Okay. Is central processing unit in a microprocessor same? Okay, execute the different rules. Yeah, close. Yeah. Anyone else want to improve Avantika's answer? Carry out different functionalities. Okay. Yeah, I'll tell you what is a microprocessor. So microprocessor is basically a programmable device or a multi-purpose device in which a set of inputs will be taken from other input I/O ports like a keyboard, mouse, or whatever it might be, and a set of instructions will be stored in the memory units, which are nothing but registers or RAM, ROM, whatever you connect it with the microprocessor. And according to the instructions provided in the memory and the data, what you get it from the what you get as an input will be processed according to the instructions, and you get a certain output for it. So mostly in microprocessors, the input will be in form of digital data. Does anyone have what is digital data, analog data? Does anyone know? Very simple, digital, analog. I think many of you would have heard. Digital data, guys, very simple.
Zeros and ones.
Yeah, awesome. So digital data is nothing but the binary data, which is nothing but zeros and ones, as said by Anirudh. Nice, amazing. So the instructions, whatever is stored in the RAM also will be in the form of digital data itself. And the input also, whatever you get it from the input devices, which will be converted into binary data and sent it to the instructions, and you get the output accordingly. And I have a question. Where are this microprocessor used? Everyone knows it is used in this laptop, smartphones. Other than that, any other uses? Okay, continuous signals are also, yeah, analog, it's same. Awesome. Okay, car ECU, nice example. Come on, guys. Few more examples. I think everyone would have seen this. Any more examples? You can speak. Okay, smartwatches, yeah, televisions, nice. Android TV, smart TVs, yeah, excellent. Any more? Sensor is not a microprocessor. Sensor is an input type output device. Maybe a system you can define. Any more examples, guys? Few more. This satellite, okay. Okay. Okay, yeah, drones, okay. But mostly in drones, we'll be using microcontrollers. Any more? Okay, let's have a look at uses of microprocessor in our day-to-day life. Okay, as everyone knows, mobile phones and laptops. Okay, now what about digital cameras? Anybody have an idea of why microprocessors are used in digital cameras? Okay, I'll tell you about digital cameras. So basically, digital cameras contain a microprocessor as a unit in it, which means like when you record a video or a photo from in the cameras, the data is in image format or video format. So there has to be like some processing has to be done, like the signal processing. When it is converted into binary form, like voice has to be manipulated. The recording voice will not be same as what you spoke. So noise suppression, all that processing takes place in the microprocessor of a camera. So that's why microprocessors are used in digital cameras, digital signal processing, image processing, video processing, all that process will be done in microprocessor of a camera. What about a traffic light system? Any idea? It's very simple. Very simple, guys. Traffic light systems is nothing but the three lights have to be glowing red, orange, and green. According to the time, according to the time you set as an input, the light will glow. So same microprocessors are used in it too. Then car parking barriers. Similarly, when the person's give when a person gives an input, the barrier opens, and according to the cam also, when a camera is placed on top of a barrier, when a car arrives, it will take as an input, process it, and opens the barrier and close the barrier according to it. Cars, as one of our friend already said, cars is an example of where you use a microprocessor in the audio system, in the ignition control. In audio system nowadays, everywhere we are using like latest technologies like Google Maps, live locations, all that stuff. So all is required. Similar to mobile. Now audio systems in cars are like similar to our mobile phones. You can use audio, FM, then USB, all that stuff. So we need a microprocessor in cars too. Now, have you heard of stepper motor anywhere? Anyone? Stepper motor. I think you people know what is a motor. What do you think is a stepper? The word stepper means. If you have heard about the word, just raise your hand, or if not, I'll explain it. Okay, no one has heard about this stepper motor. So basically, a stepper motor is similar to a motor, whereas in this, the angle of rotation is defined, is in the form of steps. So one step, a motor can have a different angle of rotation, which means a motor can rotate 1 degree per step or 2 degrees per step, or depending on the motor. So when you set it as 1 degree for every step, suppose you give number of steps as 100, then the motor, after every time gap, like it'll rotate 1 degree, wait for 1 second, rotate for 1 degree, wait for second. So it is in the form of steps. Work, pause, work, pause. So that is how a stepper motor works. So these stepper motors get the processing from microprocessors. This stepper motors are used in 3D printers, DVD drives, CD-ROMs, then whole entire audio systems, like where you put DVD, you listen to tape recorders, they say, or all this. So these stepper motors are also used in robotic links, like robotic arm links, where the robotic arm is like, now how your shoulder works, the joint. Similar to that, the stepper motor link is present at that position to the robotic arm. So depending on the amount of rotation, the robotic arm rotates. Depending on the steps, number of count of the steps, required amount of angle of rotation. So like that. Did you guys understand? Or like you want me to repeat or something? Just react, guys. Raise your hand if it's okay, or you want me to repeat.
Can you explain again what is stepper motor?
Okay, stepper is nothing but steps. Remember it in the form of steps. Steps is nothing but, suppose you walk, you walk. Each step you cover 10 centimeters. Like just depending on the way you walk, you cover 10 centimeters. Similarly, in the motor also, it will rotate depending on the step angle. Suppose if you mention it as 1 degree, the motor will rotate only for 1 degree and pause. Again later, you'll give a time gap depending on your requirement or the speed, how fast you want the motor to rotate. So it'll take 1 step, pause, again the second step, pause, and third step like that. If the time gap between the steps is very less, then it's like fast, normal motor, it will rotate continuously. If the time gap between the steps is more, then you can feel it. It'll rotate 1 degree, it'll wait for 1 second. Then again it'll rotate for 1 degree, it'll wait for a second. So that's how a stepper motor works. Just like how the way you walk, the steps. Got it, Rohit?
Yes.
Yeah. So it is used in DVD ROMs, all that stuff, and robotic arms, links, etc. And now let's go to the specifications of microprocessor. Okay, you all of them have bought a laptop which has microprocessor. Okay, what are the specifications you see while buying the microprocessor? On what basis you buy a microprocessor? One of the major factor everyone thinks about a microprocessor is. Come on, guys, just text.
Memory.
Does microprocessor have a memory? Okay, that when you'll think about memory when you're buying a laptop, but you for the speed, what do you think? Like, for the performance, I mean. Okay, course, yeah, correct. Course is correct. Okay, speed is also correct. Any more? I think these are the most important. Yeah, what Avantika and Navya has said. Great, guys. So basically, while designing a microprocessor, they think about instruction set too. So what is an instruction set? Well, when you code or when you put the set of instructions in your memory, different microprocessors have different way of instructions. Like, for C++, all that stuff, you measure int, float, as you have all studied in first year, second years, in your previous years. Similarly, every microprocessor has its own instruction set. So based on that, a microprocessor is also defined. Now the next thing is instruction length. Basically now anyone knows, like, how much int is, like int size, float size, like that. Even the instruction, it will have a certain amount of size in which it will require to store. So few instructions, like complex instructions, require more amount of data, like storage space. Few will require very less. So depending on that also, microprocessor is designed. Next is the clock speed. Clock speed is nothing but speed, what your friends have said. Speed, it determines the number of operations per second the processor. So more operations per second, the faster the speed. Previously, in older times, like now in this era, we have mostly gigahertz. Before like 20 years, the microprocessor at the starting 8051, 8085, all that had in megahertz, which are very slow. Basically, now in this era, it's in gigahertz, so they're super fast. That's why we're able to do our work like smooth, all this. It can also be called as clock rate, same, or not, just speed. Now you have your laptop in 2.4 gigahertz, basically 3 gigahertz. All these are the clock speeds of your microprocessor. So more the clock speed, faster is the processing power. Now word length. Word length is nothing but the width of the ALU. ALU is nothing but arithmetic and logical unit, which I'll be saying in the upcoming slides. So for transferring of data from memory, the storage space, nothing but ROM, RAM, or the registers present in the microprocessor to different locations required a way, like a path, nothing but a road, I can say. So the width of the road is like 30 feet, 100 feet, Similarly, in a microprocessor, there's something called word length, width of the bus. So at a time in arithmetic logical unit, you can process 8 bits. So as an example, internet data bus registers, all this have this word length, depending on it, 8-bit, 16-bit. Can you tell me what is a bit? Already you people know it. Previously I've discussed. A bit is nothing but a 1 or 0. So 8-bit means 8 digits of ones or zeros can be transferred at a time through the bus, and it can be calculated. Suppose an addition is performed of 8-bit, 8 digits of zeros and ones can be added at a time to that. So that depends the word length. Next, what is an architecture. That's how we started our presentation today. Architecture is nothing but the way you design the system for its functionality, performance, and few better reasons. Now, microprocessor has basically 3 main components in it, which is nothing but ALU, control unit, and register array. as I've already said, ALU is nothing but arithmetic and logical operations. ALU, arithmetic means you all know. I think you are studying from your UKG, addition, subtraction, multiplication, division. All these actions will take place here. Logical, greater than, less than, all these comparison things takes place. So ALU does all these functions in it. Next is the control unit and timing and control unit. So what is okay, I'll tell you about timing and control unit next after. So registers are nothing but the storage space present in the microprocessor where you can store data, the required data or the instructions, the code, what you normally store, right? That will be stored in registers. So registers are of different lengths. It can be 16-bit register, 88-bit register. So depending on that. Now let's go on to timing and control unit. So timing and control unit is the most important part of the microprocessor, where that's the reason behind of functioning of all the processors. Now basically, as in the flow, first you get the data from the input device, then it stores in the registers according to the data or instructions, and it stores in the registers. Now the control unit, which fetches the data from the register unit and through the data bus. Through the data bus, it fetches the data from register array or memory unit and sends it to control unit. Once the control unit sends the instructions in order, sequential way, to the required component depending on the instruction. So control unit is like basically it will take the data from different sources like memory unit, register array, all that stuff. Then if it's an arithmetic or logical operation which has to be performed, then it will send the data to ALU or it will send the output device. So all this takes place in control unit. And the timing unit. The timing unit is nothing but already the first step has gone. So until the first step has been completed, it will wait. So after that is done, the timing unit will send the second step, second instruction. So it won't collapse. So it will go in a sequential order without any disturbance or hazard. So that is the main function of timing unit. So guys, you have any doubts or you felt anywhere any difficulty or anything? You want me to explain anything? Or is it comfortable to you? Just raise your hand. If you're okay, we'll move forward. Come on guys, quick. Let's go. Okay. Okay. Now my friend Dinesh Kumar will speak about microcontroller, where that is the most important part for the robot, where our main motive is. So Dinesh, over to you.
Yeah, thank you, Ritvik. That was awesome. So yeah. So guys, I hope you have got a basic idea about architectures and microprocessors, right? It would be nice if you give a thumbs up at least. Okay, kindly repeat about registers. Ritvik, can you reply to our chat in the chat box so that you can help her?
Yeah, Dinesh, I'll try, definitely.
Okay. Yeah, guys. So okay, I have seen some thumbs up there. Okay, let's move on to microcontroller. I think you all might know about microprocessors because we are using it every day. But I'm not gonna ask you anything about that. But I just I want to ask you something like, have you ever had an experience with a microcontroller? I mean, in terms of a product, or you have used it? Have you? Do you have any idea? Like you would have probably used it or not? Come on, just I need some guesses. Just think you might have used some product which involves a microcontroller. Come on, guys. I'm sure you might have used it, but you may not know it. Just give it a guess. I'm not gonna judge your answers. Like I just want your guesses. That's all. Performs a specific task. Yeah, washing machine. Yeah, that's correct. Really great. What else? Okay, washing machine. It's yeah, TV remote. Okay, that's a good answer. TV remote. Yeah, that's okay. We have been using it from a childhood. I mean, what I need, I am expecting another answer. A basic one. We have been, pretty much interested in that from our childhood itself. Okay, let me give. Shall I give you a clue or what? Car engines, mobile. Oh no, mobile. I don't think so. Maybe car engines. Okay. Yeah, it is used in car engines. I guess. Yeah, it is used. I think. Okay, like I don't know how many of you remember. Calculators also correct. I think. Yeah. How many of you remember? During my childhood days, I used to tie a rope in my, a small toy car, and I used to pull it around my house. Just to follow me. It was a good experience. Come on, guys, I've given you the clue. Like, just tell the name, the toy at least. Okay, I'll tell you. Yeah, we have been using it from our childhood, and that is a remote control car. Oh, some would have guessed. Yeah, that's great, Sweta. That's correct. Okay, then. Now let's move on. So the basic definition of a microcontroller. Yeah, it is a VLSI integrated circuit chip, very large scale industry integrated circuit chip. Yeah, this is the basic definition, but let me put it in a simple way. You can call a microcontroller as an integrated circuit or a chip, that is programmed by a human being to do a specific task. Let me repeat it again. It is an integrated circuit or a chip that is programmed by us, to do a specific function or a task. Okay, and you can also call it as a mini computer sometimes. Yeah, it is a mini computer in a sense. Yeah, so this is the basic definition, guys. Let's move on to the to see the core elements of a microcontroller. Yeah, so okay, there are three core elements. They are the CPU, that is central processing unit, and the memory unit, and the input-output ports. Let me brief you on these three core elements. Okay, we know the central processing unit is obviously the brain of the microcontroller. We have been saying that the robot has a brain which is called as the microcontroller. But here we have the central processing unit as the brain of microcontroller itself. So please understand, like the brain of the microcontroller is the central processing unit, where it processes and responds to various instructions, and it is responsible for the function of a microcontroller. This central processing unit does basic arithmetic, logical, and input-output operations. These three are major operations that are performed by a central processing unit. It can also transfer data. It can also transfer data, and which communicate commands to other components in in larger systems. So yeah, this is the brain of the microcontroller. Next, moving on to memory. Yeah, there should be a memory to store the programs. The way it should perform, right? There should be a set of instructions stored somewhere. So we need a memory unit for that. So yeah, so the memory unit is divided into two parts. That is, as we all know from our mobile phones, we have a read-only memory and a random access memory, the so-called ROM and RAM. So yeah, read-only memory and RAM. Let me elaborate on that. So we can call the read-only memory as a program memory, which stores the long-term information about the instructions that the CPU carries out. Okay, it is a set of instructions basically. Like it tells the microcontroller how it should perform, how exactly it should function, and all. Okay, yeah, it is a non-volatile memory. It should be noted. It is a non-volatile memory. Why I'm saying it is a non-volatile means see if the power to the microcontroller is cut off, even though the power to the microcontroller is cut off, the data in the ROM will be there, permanently. It won't be erased if you cut off the power. But when you come to the RAM, random access memory, it is just a temporary storage, okay? And it is also called as data memory. They can be used, for storing some temporary data, like some outputs. It's a temporary storage and is volatile. If the power supply to the microcontroller is cut off, then the stored data in the RAM will be erased. So it is volatile. I hope you understood the difference between non-volatile and volatile, right? Give a thumbs up, please. Thumbs up, thumbs up. I want the thumbs up. Yeah, that's good. That's good. Okay. Now let's move on to the input-output ports. Okay. Why do we need the input-output ports? See, without a communication between the outside world, the microcontroller cannot do anything. Like, it should know what is happening outside, and then it has to give an output to us, which is that is how it is being useful. So in order to communicate with the outside world, the microcontroller can be connected to an input device through the input ports. The input ports serve as a bridge between the input device and the microcontroller. And when it comes to output, the output devices are connected to the microcontrollers through output ports. That is the use of input-output ports. So remember these three things. The basic elements are my CPU and memory unit and the input-output ports. Okay. Now, yeah, let's move on to the next slide. See, okay, so microcontroller unit can be called as MCU. Yeah, it is. This MCU is, it almost attracts everyone in this world. Yeah. So we'll be calling a microcontroller hereafter in this presentation as a MC or MCU. So please don't get confused. MC or MCU is a short abbreviation of microcontroller. And it is also called as an embedded controller. Embedded is a new word, it seems. Does anyone know about embedded? Have anyone heard about embedded already? If you know, just raise your hand, or you can put your answers in the chat box. Because I'm really interested in knowing who all know about embedded. If you know, then you are brilliant. Yeah, embedded systems. Yeah, that's correct. Yeah, you are brilliant, right? You know about embedded systems already. Okay. So what does the word embedded mean? It means built into something. It is built into the system and not on the system. It is built into the system. It is a permanent part in a bigger system. You must understand that embedded system is it is like a permanent part in a bigger system. It does not usually look like a computer, often no keyboards, no monitors or mouse, but it is like any computer. It has a processor, software, input and output. The only thing is it does not look like a computer, but it can do all the things that a computer can do. Yeah, so embedded controller, it is a powerful one only, It is a good competitor of a computer. So I hope you understood what an embedded controller means. So yeah, let's move on to the next slide. See, as you have already seen, microprocessor, it is connected to the memory, input-output ports, and clock externally. Not my word, externally. Without these things, without the memory, input, output ports, clock, the CPU cannot work. It cannot work without these three components being connected externally. Okay, so what if I say we can put all these together into one entity? and that is called as a microcontroller. Yeah, it's pretty interesting, right? Like you have everything inside a one single package. That is called as a microcontroller. Guys, do you understand what did I mean by connecting externally and you know putting everything into a single entity called microcontroller? Guys, did you understand? Come on, or else I cannot move forward. You understood the difference between how the microprocessor and microcontroller architecture is, right? Okay. Yeah, only few thumbs up. Do you want me to repeat? I can see only few thumbs up. At least just say a repeat or. Can I move forward? Yeah. Okay, then I'll move forward. Okay, okay. Yeah, thank you, thank you. Okay, so you'll see the principle of operation. Oh, you want me to repeat? Okay. See, can you go to the previous slide to take? I'll just say one more time. See, first, you know, a microprocessor is like a single entity. It can just only process data and output data. Like if you just give an input, it will process and give a specific output. Only if you connect the memory unit, input output ports, and clock externally. Microprocessor doesn't have a memory input output clock internally. They won't be inbuilt in them. You have to connect them, and then only they can work. But in case of a microcontroller, everything is put into one single chip. So you don't need to connect them externally. So that is what a microcontroller is. I hope you understood. What is in the upcoming slides you'll get to know better. Okay. Yeah. So moving on, principle of operation. Microcontrollers are used for specific applications. What does that mean? See, a microprocessor is used in mobile phones, laptops. What kind of operations do we do in laptop or a so-called mobile? Can someone tell me what kind of applications we use in laptops and mobiles? We play video games. We can browse. We can edit an image. A lot of things. We can do a video call. A microcontroller does a lot of things irrespective of the input we give. But in case of a microcontroller, it can do only a specific task. If you give an input, it just processes that data and it can do only the specific operation. It is used only for a single task and not for numerous tasks. Okay. I'll give you an example about it. Don't worry. I will give you an example. Then a microcontroller need not be powerful. See, the first point explains, because it is not going to, perform many tasks as a microprocessor. So it need not be powerful. It just needs the right amount of power to do that specific task. So it need not be very powerful. So next point is we have a microcontroller needs to be programmed to be useful. Yeah. So for this point, I'll tell you, like if I have a LED, a small LED bulb, and I want it to turn on if I press a push button. So I can write a code for this. Okay, just imagine. You don't worry about the codes and all. I'm just giving an example. It's just a simple operation that I should press a button, the microcontroller should receive the input, and that it will turn on the LED. And it requires a simple code. But what if there is a complex operation? So yeah, the program that you are using the microcontroller decides the usefulness of the microcontroller. That explains the fourth point also. Yeah. So okay, guys. Is it okay, or should I? Is there any discrepancies? I mean, do you have any doubt, or should I go slow? Want any replies? I feel like I'm alone. Okay, one thumbs up, two thumbs up. So I understand. Okay, I think you have understood. I hope you have understood. So I have been telling you that I will write, some codes to do that specific operation, right? So how do we program a microcontroller? Guys, so how many of you know C, C++, Python, or any programming languages? What kind of programming languages do you know? Come on. And where do you input, like where do you type those programs? What kind of IDEs you use? Come on, list some of the IDEs you have used so far. List the IDEs. VS Code, yeah, that's a famous. Eclipse, oh my god, yeah. Python IDE, yeah, that's great. Any other? There are a lot of IDEs nowadays. You must have known. That's good. Arduino IDE, yeah, man, you jumped directly into the point. That's nice, Venkatraman. Spider, yeah, that's good. That's great. Okay, NetBeans. Some of you have already known about Arduino IDE. That's really great, really great. Okay, then yeah, it's a good answers I have got. Yeah, so like as we all do for normal programming languages, for microcontroller also we need IDE. We can write in an IDE text box, a text pad, even a notepad, or anywhere. Okay, so you can input the program there, and then second point, yeah. So what kind of programming languages you use? So there are some examples like C, Basic, or assembly language. What other programming languages do you think will be used for controlling a microcontroller? Do you have any idea? Any guesses? I just want to know. Any guess? Any guess? Other programming languages that can be used to control a microcontroller? Okay, let me tell you. Like C, C and C++ both combined to use, to control the microcontroller. Java, okay. I'm not sure about that. Java, okay. Let's see. Yeah, Python. Python can be used. I'm sure about that. Python, Java, C, hashtag. I want to give you some additional information here also. How many of you know about MATLAB? Raise your hands. MATLAB, Simulink. Anyone knows? Raise your hand. Yeah. Okay, there's two others. Oh, really great, guys. MATLAB, Simulink. And did you know we can use those software, like we can use those tools to control a microcontroller? Okay, yeah, this is for your information. We can use MATLAB and Simulink for controlling a microcontroller as well. Okay, after, the programming part is over, then what does the IDE does? Okay, then the IDE debugs the codes for errors, because with the errors, the microcontroller cannot work because it cannot tolerate the errors. So it will prompt us the errors, then we'll rectify it. And the compilation process, it compiles the code into a binary codes, which can be understood by the microcontrollers, because microcontrollers cannot understand the human language. So it has to be in the form of binary codes, that is zeros and ones. I hope you understood it. First, we have to write the program, then it debugs, then it compiles into a binary code, which the microcontroller can execute. So how do we upload this code into a microcontroller? There are a lot of ways. One of them is the programmer. It is a hardware and not a person. It's not a human. It is a hardware that is called as ICSP, In-Circuit Serial Programmer. You don't have to worry about that much now. It's just for information. We can upload the code through USB as well. USB is also possible. And one of the hardwares which is used is ICSP. Okay, just remember that. Don't worry about that. Okay. Let's move on to the next slide. No doubts, right? Any doubts? One, you can ask any doubts. Okay, so move on to the specifications. As you've already seen in the microprocessors, here we have the clock speed of 1 megahertz to 300 megahertz. And RAM ranges from 1 kilobytes to 256 kilobytes. And flash memory, 32 kilobytes to 2 MB. The peripheral interfaces used are UART, that is Universal Asynchronous Receiver Transmitter. I2C, Inter-Integrated Circuit. SPI is Serial Peripheral Interface. Okay. Okay, I think, does anyone know about flash memory? Yeah, why no one is asking about flash memory? I assume you all know that. Who knows about flash memory? Come on, tell me. No one, huh? I guess no one knows about flash memory. Yeah, don't worry about that. Flash memory is nothing but it is a ROM only. It is a read-only memory. It's just named as flash memory because in read-only memory, most of the microcontrollers does not use read-only memory because, in read-only memory, you cannot change the set of instructions or programs that is being uploaded in it. Yeah, non-volatile storage. Shit, that's correct. The only difference between a ROM and flash memory is, you cannot change the program in a ROM, but in the case of flash memory, you can, modify the program or change the program, use this flash memory, which acts like a ROM. So don't confuse between a ROM and flash memory. It's almost similar, just that you cannot erase in ROM and you can erase in flash memory and upload it with a new code. And it is what needed for a microcontroller. So it is really important. And peripheral interfaces. Yeah, we can also store it when it went off. So it went off. Yeah, we can store it. This is non-volatile memory. That's correct. And clock speed 1 megahertz to 300 megahertz. You might be wondering, why microcontroller has such a less specification? I think I have answered you already. Can someone, give an answer why these specifications are very lower than the microprocessor? Does anyone have an idea? Because I've already told you in the previous slides. I've answered you, I guess. Come on, just
As it's going to do only one work now.
Yeah, that's
specific work.
Exactly correct. What's your name? Raghunath. Okay. Yeah, that's correct. You're correct. Because they don't need much of power to, execute the task. So that's why they are in the range of 1 megahertz to 300 megahertz. But in the case of a microprocessor, it is from gigahertz. It starts from gigahertz. That's correct. Be powerful. In case of RAM, it's 1 kilobyte to 256 kilobytes. The same reason, because the operations that is going to be performed by it are going to be too small. So it may not hold a lot of memory for temporary storage. And peripheral interfaces. Can anyone repeat the abbreviation of UART? I can see anyone. Did you remember any one of them? I've said 3 abbreviations: UART, IQC, and SPI. Come on, just remember. No one guesses. I think no one remembers, I guess. Okay, let me tell you, UART. Oh, someone. Yeah, come on. Someone said something. Okay, so I'll repeat it again. UART is what? Okay, let me begin with what UART is. UART is, it is a communication protocol. And yeah, serial peripheral. Yeah, that's great, Sherlyn. Yeah. I hope you paid attention. I am happy that you paid attention to listen. Okay, UART is a intercommunication protocol. What does that mean? Intercommunication protocol, what does intercommunication means is the communication between a laptop, that is a laptop and a microcontroller is called as the intercommunication. And intra-communication is the communication within the microcontroller. Okay, hope you understood the difference. So UART is based on, it is one of the, it is one type of, inter-communication protocol. And I2C and SPI are intra-communication protocols. And you don't worry much about it. I think you don't need it for now. Like, just know about it. These are communication protocols. Okay. Let's move on to the next slide. Does anyone have any doubts? Anyone any doubts? Thumbs up, please. Come on. I just need to know you understood or not. As microcontroller is very important, so please pay attention, and if you have any doubts, just ask it. Please don't skip it now. You might struggle later. So yeah. Okay, only one thumbs up. Okay then. So let's see. I've said you already microprocessor. Thank you guys. We'll see about microprocessor versus microcontroller. As I've already said you. The first point, you can see the microprocessor can be used for general computing, like how the things that the laptop and mobile phones does. It can process videos, images. We can play video games and a lot of stuff. So yeah, that is the general computing. And microcontroller, yeah, as I've already said, it is used for specific applications. It is obviously very fast and it is relatively slow. Yeah, the cost of production is also high because the production of processors involves complex processes. So it obviously costs high to produce microprocessors, and its microcontroller chips are there are microcontrollers which cost too much there are high-end microcontrollers also. But usually the production cost is very low in case of microcontrollers. Then we got energy usage. Microprocessors usually use a high amount of energy because of the functions they perform, and low use of energy in case of microcontrollers. Okay, let's move on to the next slide. I think you have understood the difference. So as we have, someone have already answered these questions, like washing machines and robotic arms. Yeah, robotic arms can be, you can use a microcontroller to make a robotic arm. It's just a simple pick and place mechanism. You can do that simple pick and place mechanism out of a microcontroller. Like, see how the washing machine works is you press the start button and the timer inside the washing machine, which is being controlled by the microcontroller, starts, and after the certain amount of time it turns off. Okay, that is being taken care of microcontroller. My robotic arm, you can program the motors and servos involved in use robotic arm in such a way that it performs, it follows a specific path. That's the application. Vending machines, So we have we'll give a specific input and the respective playing roles, and the product is being delivered to us. Yeah, these are some of applications, but there are a lot of applications out there. Please go through it also. Okay, moving on to the next slide. Okay, what is interfacing? Guys, come on, can someone tell me what interfacing is? Yeah, try to give some examples of microcontroller used in your home, like washing machines, remote controls, what else? And can you tell what interfacing is? What does the term interfacing mean? unmute and you can unmute and tell. No worries. Or you can put in the chat box also.
Communication between user and the machine now.
That's great. That's great. That's a good answer. Transferring data. Okay. Yeah. Ultimate. Yeah. That's very good answer. Both were correct. Yeah. Transferring data is the apt answer for that. Okay. Now let's see. Okay. We need, as I've already told, we need communication between the outside environment to, make the microcontroller work. So first one is like the sensors. What kind of sensors do you know, guys? I think, did they cover in yesterday's session about sensors? No, I think not yesterday's. Any sensors do you Yeah, so next we have keypad. Keypads are used for giving inputs to the microcontroller. Then we have using keypads. Then LED. LED is an output source which can be used connected to the microcontroller. Then LCD to display data which are being processed by a microcontroller. Then motors like servo motors, stepper motors, which is being used in robotic arms. Then we have other microcontrollers as well. You can make a microcontroller powerful by connecting other microcontroller with it. Yeah, it is about interfacing. Well, let's move on to the next slide. Okay, I just wanted you to show some of the microcontrollers out there. The most popular one is ATmega328 and ESP32. Just go through, guys. There are a lot of microcontrollers. These are some of them. In next slide, we will see about the development boards. Okay, just don't confuse between a microcontroller and the development boards. Okay, the most popular one is Arduino, I think. Then the Raspberry Pi. Yeah, I have to talk about Raspberry Pi. It is very powerful. Even you can make a mini computer out of it. It is very powerful. Then Node MCU has a Bluetooth module which can be used for IoT applications, Internet of Things. And there are a lot of development boards out. Okay, we can go through them. And see, this is we'll take an example, Arduino Uno. See, this is the microcontroller. Okay, the microcontroller used here is ATmega328P, manufactured by ATmel. Okay, at MEL. The whole board is the development board. We usually call this whole board as the microcontroller. So don't get confused. Microcontroller is this single part, but we usually call the whole thing, which has input output ports, serial ports, everything. The power cord, power connection, USB connections, everything. Don't worry about other parts. You just know how does a microcontroller look. Okay. Yeah. So this is development board. These holes are like input output ports. Okay, guys. I hope you got an elaborate idea about microcontrollers. I hope you enjoy this and learned new stuff. Controllers will be taken by Ritvik. Thank you, guys.
Yeah, guys. So we have heard about microcontrollers previously. You can understand by the name itself, micro, which are small in size, very usable, easy to carry. So now let's have a look on controllers. Same, controllers are nothing but it has a control system in it, which gets the input, process it, gets the output. Same. Now these the control system is basically like it has a loop. You know what is a loop? Which runs again and again, takes input, process, output, input, output. Like it happens continuously. Now, First, this diagram, you can observe this diagram. So it takes the input from surroundings and it sends it to the controller, according to instructions process it, then goes it to the processing unit output like interfacing, and you get the output. So this is basically called a open loop, which does not have any feedback mechanism or anything. Feedback is basically nothing but, see, you conduct some event or something. So you send feedback forms to the participants and you get the ratings, all that stuff. Similarly, even in this control system, we have something called feedback mechanism. So according to the output you got, you will send it to a comparing unit, which is nothing, which is an addition or a subtraction, which conducts arithmetic operations in this square near the R, less than. So near R, the output will compare with the input. So basically, it compares input and output compares. It will calculate an error E, which can be more or less. If it's more, it will be a positive number. If it's less, it will be a negative number. Accordingly, it will process. Again, according to that, the input is taken into the controller. You will get output. So this happens continuously, so that there's no lot of change. Like suppose you send a value 10, the required value also is 10. So if the output is 15, then the output 15 number is sent near the input near R. Then the difference is calculated. 15 minus 10, nothing but 5. That is calculated error. So to maintain a constant output from the processing units, we use this mechanism called closed loop, which is also known as feedback mechanism. Remember this term. Closed loop is called as feedback mechanism. Open loop is called as non-feedback mechanism. To decrease the errors, discrepancies from the with the required output, you'll use this feedback mechanism. So basically, the most popular control system or a mechanism which we use in the recent times, like in industries, it's most popular and is the most accurate and efficient one, which is nothing but PID. So the by name, the full form is nothing but proportional integral derivative controller. You get similarly in place of in the previous slide you have seen, you get the input and there is a control unit. In the control system, you have these three processes going on: proportional, integral, and derivative. Why only proportional, integral, derivative? Because proportional, integral, derivative carries over most of the arithmetic operations. As you all know, integral is nothing but addition, repeated addition. Differentiation, derivative or differentiation is nothing but repeated subtraction. Proportional is nothing but you get the division part or the multiplication part. Like suppose you got 20 as the output, then you have to divide the input by 10. So you get the previous output little lesser than the previous input. So that's a like proportional carries over multiplication, division. Integral over takes over addition. Differentiation takes over subtraction, repeated subtraction. So that is why this is the most popular and most efficient method, because it carries over all the arithmetic operations possible. Similarly, you can the same diagram was shown previously. It's just a little complex one which contains PID. And from the diagram, Kp can be the proportional constant, Ki is integral constant, Kd is derivative constant. All these values are like you have to do a few calculations in the background, or you can do guessing. Most of the times will work out. All this can be done. Now we'll use this PID in industries. I have already told. Yeah.
Sorry to interrupt. Someone wants to see the previous slide before that PID.
Yeah. Yeah, this is nothing but a loop, a feedback closed loop. So in place of this controller system, that is nothing but CS, we place a PID controller. So in a control system, we have controller, plant. Plant is nothing but the processing unit. So in place of controller, we'll place a PID controller. Is that okay? Can I move to the next slide? Yeah, fine. So same thing. So in our day-to-day life, in the industries where they use PID mostly. Okay, the first example is nothing but temperature control in the industries, like in furnaces, water heaters, all this. This is all automated, so no one is going to handle this or maintain the temperature of the like the content inside the tank. So to make this automated, we use a PID controller in place of a control unit and try to maintain the temperature constant inside the tank. So the temperature is not always constant. If you keep heating, the temperature will go like above, not at, it won't be at a constant temperature. So even in water heaters, you can think there's a control unit which maintains the if you set a temperature in a water heater, then it will be at the same thing, which is nothing but a PID which uses that. So if the temperature is over the set, like 35 temperatures you would have set, if it's gone above that, then the difference, like 35 is sent to the input, you will calculate the required one. 35 minus the output, what you got, suppose 40 degrees Celsius, 5 is sent to the error, then the input accordingly is decreased again. So depending on the output, the input is changed. It can either increase or decrease. Similarly, in water heater for maintaining temperature, whereas in wheels, PID control is used mostly in wheels of a bot. You know, all the wheels, basically what you think is all the wheels are like moving straight, like rotating at the same direction. It is going in a straight path without any deviation. But practically that doesn't happen. The wheels of a bot rotates with different speed because of the opposition, like friction or some opposing force. The rotation, the amount of rotation is varying, like in minute degrees, like 1 degree or something. So to make it correct, if even in the change of, like suppose the right wheel is 1 degree slower than the left wheel, then it might take a right, like it might go towards slant, like towards the right side. If the wheels are the same speed, then it goes right, then whichever is more, then it goes according to that direction. So to make it constant, to make it go in the straight way path without any deviation from the path, you use PID controller. So you get the amount of rotation from each angles, compare it with both left wheel and right wheel. Accordingly, if left wheel is more, then you decrease it in the next step. If right wheel is more, you decrease in the next step. So that's what happens in a PID controller for the bots. To maintain same amount of rotation in the wheels of a bot, PID control is used. So now let's have this code is for your reference. You can easily understand if you go through it, like the same calculations, integral, derivative, all that is used. From the loop diagram itself, you can understand the logic. Just go through it after it. If you have any doubts, you can speak, ask. So let's have just a video brief about PID control, what we learned from starting. The whole video says what you have spoke in the previous slide. So just brief. So this is where we have spoke of the first example, temperature control of a blast furnace or a tank water heater or something like that. You can see the loop, how it goes. The sensor will identify the water temperature in it, then it sends it to the controller. Accordingly, it will vary the input. So that's a brief video. If you want, you can have a look at it once more. Even this is an example of car, guys. Once cruise control in cars, right? These are just simple examples, guys, to make it understand easily for you. You can Google it, get to know more about it, PID controls, where it is used. A lot of learning is there, and about PID control. Just Google it and get to know it. Many YouTube videos are there. Yeah, that's all, guys. That's all for today. Thanks for your time. Even though we took the session for long, we wanted it to be more uh, content and to reach out to people easily. So that's all, guys. Any doubts you can shoot over in the text box, or you can say how the session was. If you have any doubts, you can contact us. Anyone in the WhatsApp groups. We'll stay 5 more minutes, or you can unmute and
Thank you
speak.
guys for being patient for so long. Thanks for comments if you see.
Yeah, WhatsApp group links were shared in the mail, Avantika. You can just go there. Or my friend Dheeraj will share you the WhatsApp group where you can join, you can ask questions. Even Discord server is there. Yeah, we'll definitely share the PPT.
Yeah, it will be shared. Make sure you join Discord. Okay, quitting, right?